Hello dear students. In the last video, we solved one problem on isomorphism. So we shall solve another problem now, the second problem in this video. So let us consider the two graphs G1 and G2, and let us verify the two graphs are isomorphic. Okay. So now again we shall check whether all the conditions, four conditions are satisfied. So let us first find the order of both the graphs. Order of G1. How many vertices are there? A, B. 1, 2, 3, 4, 5, 6, 7. What is order of G2? That is also 7. A dash, B dash, F dash, C dash. So if you count, there are 7 vertices. Next, let us consider the size of G1. How many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 edges. What is size of G2? Size of G2 is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 edges. Now, degree sequence. Degree sequence of G1 is equal to, okay, so you can you can start from any vertex and find the degree sequence. So degree sequence of A is 3, next B 2, E 3, F 3, G 2, C is 2, degree of D is 3. Now consider the degree sequence of G2. Degree sequence of G2 is, let me start from A dash. 3, F dash 2, B dash 2, C dash 3, D dash 3, E dash is also 3, G dash is 2. So now you are very much familiar with how to find the degree of each vertex of a graph. Now you can see that 4 vertices are of degree 3 and 3 vertices are of degree 2. You can see 4 3s and 3 2s in both the graphs. Therefore, the degree sequence of G1 is equal to degree sequence of G2. Next thing is the correspondence. A, B, C, D, E, F, G. These are the vertices of G1. Let us see what are the vertices of G2 to which these vertices are corresponding. Okay, are mapped. Now, let us start from vertex A. Vertex A is of degree 3, which is adjacent to 3 vertices C, B and D of degree 2, 2 and 3. 2, 2 and 3. Now you have vertices of G2, okay, A dash, E dash, D dash and C dash of degree 3. So out of these 4 vertices, to which vertex I should map A? Suppose if I consider A dash is of degree 3, but it is adjacent to F dash of degree 2, D dash of degree 3 and E dash of degree 3. Here I have 2, 2, 3. Here I am getting 3, 3, 2. So I cannot map A to A dash. If you consider E dash is of degree 3, adjacent to vertices of degree 3, right? And degree 3, degree 2. Again, I cannot map A to E dash. Now if you see D dash is of degree 3, which is adjacent to the vertices of degree 3, 3, 3. So again I cannot map A to D dash. C dash is of degree 3, which is adjacent to B dash, D dash and G dash of degree 2, 3, 2. Hence, I should map A to C dash. Clear? Then now next let us consider B. B is of degree 2 and it is adjacent to A, adjacent to E of degree 3 and 3. Now already you have A dash, let me consider vertex of degree 2. So suppose if I consider F dash, which is a vertex of degree 2, it is adjacent to A dash of degree 3 and B dash of degree 2. So I cannot map B to F dash. B dash if you take, it is adjacent to vertices of degree 2 and 3. Again I cannot map B to B dash. G dash if you take, G dash is adjacent to E dash and C dash of degree 3. So I can map B to G dash. I can map B to G dash. See, B is adjacent to A. So if I map G dash to B or B to G dash, B is adjacent to A because already I have correspondence between A and C dash. Therefore, B is adjacent to, B is mapped to G dash. Now let us consider, so I'll just name it as B. Next, E. E is adjacent to B. So I should find a vertex of degree 3 which is adjacent to G dash in the graph G2. E is adjacent to vertices of degree 2, degree 3, degree 3. So I should find a vertex of degree 3 which is adjacent to G dash and 2 vertices of degree 3. So can I map E to E dash? E to E dash? Yes. Because E is adjacent to B. E dash is adjacent to G dash, which is having a one-to-one correspondence with B. So I can map E to E dash. Next, E is adjacent to F. So I will just consider F. F is a vertex of degree 3 adjacent to E, adjacent to D, adjacent to G of degree 3, 3, 2. So let me check if D dash can be mapped to F dash. So D dash is of degree 3 which is adjacent to A dash, E dash and C dash of degree 3, 3, 3. So I cannot map. Correct? Now I am left with this vertex A dash. A dash is of degree 3 which is adjacent to E dash, D dash and F dash of degree 3, 3, 2. And therefore I can map F to A, F to A dash. So you can see that FE is a vertex. So FE is a vertex. Is that clear? Or A dash, E dash is a vertex. Sorry, A dash, E dash is an edge. Okay. Next, let me consider D dash. D dash is adjacent to A, E, F of degree 3 each. So I am left with only one vertex of degree 3 which is adjacent to A dash, E dash and C dash of degree 3, and therefore I should map D dash to D or D to D dash. Now C, or let me consider G. G is a vertex of degree 2 adjacent to F and C of degree 3 and C. So we are now left with F dash and B dash. F dash is of degree 2 adjacent to a vertex of degree 3 and 2, and therefore G should be mapped to F dash. So we are left with only one vertex, that is B dash, which is C, which is mapped to C. Now if you write the adjacency matrix of both the graphs, okay, by taking the by labeling each of the rows of G1 by A, B, C, D, E, F, G, and each rows of the second graph G2 by the same order C dash, G dash, B dash, D dash, E dash, A dash and F dash, we get both the matrices the same. So this implies that G1 and G2 are isomorphic. Thank you.